era of smart city, is it not weird that this man just missed his bus? Now this man is waiting for his bus, knowing not when it will arrive. So, here lies the motivation to our project. What our project does is, it will provide estimated time of arrival of this bus to the user.
Before we start getting into the technical details of our project, let me give you a brief overview of how it works. The way it works is that user receives an SMS of the location of the bus, and when the user opens it, he gets an estimated time of arrival of the bus. In this way, the user can conveniently know the arrival of his bus and can conveniently plan his journey according to that displayed information.
Now let me introduce you to our hardware requirement which we are using in our Arduino based projects. Here we are using a GPS receiver and a GPS antenna through which we are getting a GPS data in our serial monitor. Here we are using a Arduino GPS module interface in which we have taken a code of GPS receiver and connected a RX-TX pin of a GPS module to the 10th and 11th pin of the Arduino board and also make a ground to both of them. And here we are powering a GPS module with a 12 volt battery, and instead of this you can also use a DC adapter and you can make a power supply. And after this compiling a code, you can verify and compile and see your result on your serial monitor.
Now let me introduce you to the software part of our project. You can see that we are using the header file tinygps.h, which helps us interact with the Skylab's GPS module. In the setup part of our code, we are setting up the baud to 56700 baud, which is the baud specified by the Skylab's gears, and we are using it to communicate with the GPS module. While coming to the loop part, you can see that the first line or the most important line of the code where the code begins is if my serial available. If the serial is available, then we enter this part of the condition, otherwise the loop resets again. If the serial is available, we read the data that has been coming from the GPS module and we print that its longitude and latitude. Now coming back to the serial availability is decided by the frequency of the GPS module. In our case, it's 60 Hz. And once we receive the data, we are showing it to the user on a serial monitor.
Finally, the code is up.
The data which just saw was requested by the user and is sent to the user in the form of link in the user's phone. As the user opens the link, the Google Maps pops up which shows the current location and estimated time of arrival.
Now let's see our project in action.
Now we are standing here ready to transmit our GPS data. You can see that we are reading it this time without using a power cord, using a 3 volt power supply which is being transmitted from the Arduino board. This data is being sent to Prakshal for the info, and once Prakshal is ready at his end and we are ready at our end, we will begin our journey.
As you can see, the requested message just arrived with the Google Maps link. The timer has started. And it should take exactly 4 minutes from the farthest route.